Again, welcome to Research Methods in Computer Science Society. This is CS 312 class. In these lectures, we're going to discuss about how to enter and also organize quantitative data. And these lectures again cover chapter 9 of the course textbook, and it's entry and organizing quantitative data. So our main objective is to explain the purpose of entry and also organizing data logically. Also, we're going to summarize the steps needed to prepare to enter data. Also, we're going to describe how to organize and input variables and their information. So first, we start with the purpose of entry and also organizing quantitative data. And they give us three main reasons here. First, to place the result in the various categories where they belong. Second, to remove or fix any information that affects our study or our analysis. This is a very important step. For example, most of the research we do in computer science, we use secondary data. So secondary data is a data that has been already been used by other researchers. So they have already prepared the data. They follow the data preparation process, everything. Now, if you are using a primary data and you went to the field and collect the data, for example, using a survey questionnaire, a very good field would be public health, where there's maybe outbreak of a specific disease. We may go to the venue and collect the data manually, maybe using a survey questionnaire or just observing the participants or observing people that we are interested in. So in this case, we are going to collect data manually. And when we come back, we want to use computer application to analyze this data. So this means, again, we have to convert this data to digital format in a way, and not only converting it to digital format, but we also have to change the format based on the application we are using. So if I'm using Excel or SAS or SPSS, maybe the format will be different, or Weka. These are all data analysis applications. So it's very important that we remove or fix any information that will affect our studies or analysis. In statistics, we talk about outline data. Maybe we collect this data and the participants by mistake enter an age instead of maybe 10 years, he enter 1,000 years. Or sometimes there's some data that the participants don't want to release the information for privacy issues. So we may have a missing values or the error again. Sometimes also we may have duplicates. So again, this is what we are going to discuss in these lectures, the process of, again, preparing your data preparation process. Also, the last step, they say, if we fail to do this, especially removing or fixing any error in the data set, it will surely affect our result. It will surely affect the analysis final result. So preparing for data entry. Here we say this task is a very time-consuming, Even data mining process, we say normally we spend 60 to 80% of the time in data mining tasks just for the data preparation process. And it's a very, very, very important step. And also most important thing is that you cannot get the right data to get the right results just by knowing it. It's a process of experience. We keep doing it, analysis different data, we get different results. the experience will come. Because in data analysis, we may have something we call the overfit or underfit. For example, I'm going to use a data analysis algorithm to apply for a data. Now, based on the algorithm, maybe the data will be too much or too less. If the data is overfit, it means I can build a model, a very perfect model with the data, but during the testing process, I may not get the right result. So it's a long process. Normally in data mining concept, we have a very advanced techniques of, again, preparing data. We can say data transformation. Either we are going to reduce the attributes using the most common algorithm is the principal component analysis or singular value decomposition. These two algorithms make it possible for us to reduce the attributes, or sometimes we also have to reduce the instance or the records. So it's a very long process. So this, as we said, this task is very time consuming. But online data collection tools that include, example, we know SurveyMonkey is very common, or Qualtrics or eSurvey Creator, eliminate this step. The reason why, because again, using a SurveyMonkey, the data is already in the computer system. A SurveyMonkey is an application. It's a survey application. So we enter the data already into the computer system. So all we need is to transfer the data to maybe the right data analysis application. Then if the data analysis application have a specific format, all we need to do is to format the data. So here we say that online data collection tools, again, remove the process of preparing data for data entry. Data entry means I collect the data manually, maybe using a pen and paper, questionnaire, and now we have a data entry clerk who is going to enter the data into a computer system. So when entry data, there are few important considerations we have to make. Logical formatting is very important. We need to follow a logical format. Most important also, the format will be based on the application that you are going to use to, again, analyze the data. Also, we need to review our survey before we begin the data entry to save time and frustration. And during the process of entering the data into a computer system, again, these data are manually. So they are hard copy, let's say a questionnaire. As we said earlier, some of the participants may not want to release some information. Maybe my age, I don't want to release my age, so I will leave my age blank. Or I enter my age, instead of 30 years, I enter 300 years or any amount. So during this process, we need to be very careful with a very small values or very large values, which we call the outline data. And sometimes when we have a missing value, if here we are dealing with quantitative data, so sometimes we can have a default value to replace the missing value, or we can just find the mean or the media or the mode of that very field, and then we use that. So for example, we have 10 patients. One patient, we are missing the age. So the rest of the 9 patients, we have their age. We can find the mean of the 9 patients' age, and then we give it to the patient that we miss his age. So this is another process of, again, data preparation process. In data mining, we have so many techniques we can do, because some of the data mining algorithms need to be, the data need to be the data need to be highly formatted so that the algorithm will work good. So for example, I want to apply data mining or data analysis algorithm on a data. And one field, I have a value of 20. Then the same field, I also have a value of 1 million. Well, 20 and 1 million, the difference is too much. So you see that doing analysis on this data, the 20 will not have any effect. So in data mining, we have a process of transforming this data, or we use the term normalize the data. Common techniques we can use, we call the taking the log of all the values. So that's one of the, there are so many techniques, but this is one of them. So for example, I have 1 million and I have 10. The log of 10 will give me 1. The log of 1 million will give me 6. I'm talking about log base 10 will give me 6. So here we can see that 6 and 1 very close than 1 million and 10. So these are some of the techniques for data preparation. Also very important, we have to determine how best to organize the variables. So for example, which variable should be entered first, etc. Or which variables we should even remove. For example, if we have a date of birth variable, and also we have an age variable, most likely the two are carry the same information. So we may end up removing one. And also the next is the software packages. Again, this is the most common one, but we have so many data analysis software package. In this course here, we can use Excel. Excel is very common and is very easy to get access to. It's one of the Microsoft Office suite, so it's very cheap. And also we have SPSS. SPSS is IBM application, which is very, very common in academia. Most schools use it a lot. And also we have SAS. SPSS is very good in terms of the cost. The license fee, even for academia, is less than $100 for a year. But SAS, again, is a very good. We have the programming aspect of it. You can even write a code with it, but it's very, very expensive. The license is very expensive. So most schools don't use it unless the school have, for example, advanced data analysis courses, and they may have it, or they even have a course for how to use the SAS, then they may have it. Also, statistics and data. STATA is very, very common. Even it comes with many textbooks. It comes with many statistics textbooks. Also, Minitype is very common. The JMP also very common. So these are I would say this is a very good list from the course textbook, data analysis applications. So yeah, they even mentioned most software programs have a trial version that can last for a few weeks to a month. Excel is very good price. SPSS have like 2 weeks trial version of it. Then if you decided, you can have the license. But again, most schools have it, the license already. So next we talk about the unique identification of a quantitative data. Actually, this will take us a little bit to database class. So some of you have taken a database class before. Database class, always when we have our, especially relational database, when we have our data, we at least have one field, which we call the primary key field. The reason is very simple: to remove duplicates. So example, we have Amazon company, have over millions of customers around the world. If they cannot be able to remove a duplicate in their database system, I mean, we're going to have a lot of data, maybe hundreds of millions. The primary key field will be a unique field that will identify each record or each instance in the database system. So the goal is the unique identification of each record. And for example, we can use, in the earlier days, many companies use social security number of employees or customers, but again, because of identity thefts, etc., Many, even schools will generate student ID number, unique ID number for each student. Companies, the same thing. If this is a patient in a hospital, they may have a patient ID, a unique number for each patient. And this field is important, especially if we are storing the data in a database system, which is the most common way of, again, storing our data. So the coding and code books is very important. For example, I may have a data set, and I may have a gender to be male and female, but I'm using some data mining algorithm, let's say neural networking. This algorithm only want to use quantitative data or numerical data. The reason why, because the algorithm is a function, it's a model, mathematical model, a function like a straight line function. So in this case, I may decide to code my gender as male is 1, female is 0. So here we say we determine how the responses to a specific question will be represented in your spreadsheet. We should code information in order to facilitate analysis. Very, very important, especially if the algorithm you are using requires a specific data type, then we need to code. A code book is extremely important because it is the key to your research process also. And all this coding, we have to, again, record it. We need to record it so that if further researchers are going through your data, they will understand what each field represents. So here we say participants can indicate their gender on survey as A for female or B for male. This is again another coding. So we code this information into a numerical value with a spreadsheet, for example, 0 for female and 1 for male. And we say this is a nominal or qualitative variable. Gender is a nominal data, male or female. And nominal data is the data that we cannot do any arithmetic operation. And the only thing we can do is the counting or the mode. So if I'm using regression, which we know is let's say a simple regression straight line. It's a function y equal to ms plus b. M is a slope, b is the y-intercept, and s is the independent variable. X cannot be a nominal data because you can see we have a plus, ms plus b. So I can't say female plus 20.2 or something, no. So in this case, we have to code our nominal or qualitative data to quantitative. And that's what we are saying. This is a nominal or qualitative variable, a type of variable with categories that don't mathematically relate to each other. And we cannot perform any mathematical operations on the nominal data. So here we talk about 4 different types of variable types. We start with the ordinal. Ordinal type of variable or values, and the word already is explained. Ordinal means something in order. So example would be cigarette smoker, light, medium, and heavy, or whatever in order. Or the instructor is very good, agree, disagree, strongly disagree. Or NBA game, New York Knicks first, LA Lakers second, Miami Heat third. So these are data that they are in order. So here we say the variables don't have numeric values. So which is correct because NBA position of first, second, third, I can't find the average of first, second, third, no. Or student ID or grade A, B, C, let's say pass, female, pass, fail, etc. We cannot do an arithmetic operation on it. The only thing we can say maybe greater than or less than. Then numerical variables, we have 2 tabs, which is the ratio and also the interval. Interval means 0 means something. So for example, a variable temperature is interval, because when the temperature is 0, it means it's very cold. But a variable balance in my checking account balance is a ratio, because 0 means nothing, there's nothing. Or weight, a weight of a person is a ratio, because if your weight is 0, that means you don't exist. Even a newborn baby born in a second, weight should be more than 0. So here we say again, the numerical variables, which is ratio or interval, also known as quantitative variables. And that's what we are, our topic is about, how to enter and also organize quantitative variables and values. So quantitative variables are expressed in terms of numerical values. Example can be age, income, or height. You can see that these variables, we can do arithmetic operation on them. So interval means the variable will lag a true 0. So the example I was given is a temperature. The temperature is 0, doesn't mean there's no temperature. It means it's very cold. So 0 means something. And it cannot be expressed as a ratio. So temperature in degree, Celsius, or Fahrenheit. Ratio will be variables that have a true 0 point. So example will be number of children someone has. If I have 0 children, it means I don't have no children. So again, in statistics, we go through this. Normally we start with the nominal, but we went through the nominal already, which is the first nominal, is the qualitative variable. Then we have the ordinal, then we have the interval, then we have ratio. These are the 4 major types of variables we can have in a data set. So next we talk about missing data. Actually, earlier time we explained how we can solve a missing data. So let's say if the variable is qualitative or categorical, well, I cannot do mean, media. The only thing I can do is mode. I can count. So here we can count all the items in that field. The mode is the highest frequency. So the most common values, or it can be a test, a word, then let's say it's yes, no, yes, no. If the most is yes, which is the mode, then we apply yes to the missing variable. That's one way of doing it. Or sometimes we may have a threshold, a default value. So in this case, if there's any missing data, we use the default value. So here we say participants sometimes don't answer all the questions. Again, maybe for privacy issues or other issues, or maybe forget. Then decide ahead of time how you will handle missing data. So patterns in a missing data can suggest an underlying problem. When coding a missing data, you can leave the variable blank or use a standard code like this example of a default value. Now, in data mining, in the process of the data preparation, normally we say the missing data, if it's less than 10%, it's less than 10% of the whole data set, we can ignore it or even remove the record that have a missing value, remove it from the data set or ignore it. But when it's more than 10%, then we either find the mean, or we use the media, or if it's qualitative, we use the mode counting, or if we have any default value, we use the default value. So those are the way we can handle missing data. So the next is organizing and also inputting the variables. So in a data set, each row always represents the one record, or here we say one case. So if I have 100 patients in data set, each row is one patient. And a patient consists of characteristics, like let's say the patient last name, first name, temperature, etc. So those are the columns. So the characteristics of the participants are the attributes or the columns. So each data set, in a data set, each row represents one case or one participant, and every column represents one variable, which is the characteristics of the participant. So one column can be last name, another column first name, address, etc. So here we need to choose a good descriptive name for each column and follow this practice. It's a best practice. We discuss this in database class. For example, if I create my table, and my table will be like my patients, or let's say I have a patient table. Now the column, if I want to install the patient last name, variable last name, I'm not going to name it X or Y, because if I name it X, many people who go through the data set may not understand what X stands for, unless they look at the description of the data set, then they know what X column means. So always is best practice to use the variable name, the column name that will describe the content of that column. So if last name I have, then I'll call the column last name. If it's address, I'll call it address. If it's temperature, I will not call it Y, I'll call it temperature. So then name the variables with one single word. Also, we can incorporate numbers if needed. Maybe I may have two columns which almost the same description but a little bit different. So I may say name 1 and name 2, or last name, first name. And also another advice, again, this is just a best practice. Most software may allow you to even enter about 100 characters as a column name. But here we are told to keep it as short as possible. Keep the variable length short. The maximum should be 30 to 40 characters. Again, this section is up to you. It's up to individual. Variable descriptions also is very important. When we enter the data into the computer system, actually, if you are using Excel, we may have the first column will be the attribute name or the database name. The second column will be the data type. Data type is important. That tells us what type of data we can put in a variable. So if I'm using Excel, let's say I have a column name, last name. The data type will be text. Text means we can put the characters from A to Z, or 1 to 3, or any symbol. Then the third column will be the description of the variable of that very column. So description is very important. Also, notations for responses. So we need to define our answers choices before beginning the data entry. So for example, here, what does the number 5 represent in, let's say, married status variable? Maybe 5 represent divorce, or married, or single, etc. So we need the notations for all the responses. Also define our answers choices before we start to enter the data entry. Also, we need to store our notations separately. In database system, we have something we call the metadata. Metadata means data by the data. So normally that information is about how the data is organized in our database system, like the name of the columns, their data type, their fields, etc. Also, we need to be concerned about scales if we are using values. So for example, we may do some studies whereby we have a nominal data answer, effective, not effective, or good, bad, etc. But the analysis we want to do, let's say we want to do a t-test or some parameter test. In this case, I can't use that values. So I can transfer it, for example, using the Likert scale. So Likert scale means, okay, if it's 1, that is good, 2, bad, etc. So that's the value I'm going to use. The reason why, because I'm doing parameter testing or hypothesis testing. Here also they say psychometric scales are universally accepted measures that ensure accuracy and avoid subjectivity. So for example, we should ask participants to state their income using the income ranges. Also, the skills are useful when measuring difficult concepts such as acculturation and the strength of the relationship between the parents and also the children. So this will be the conclusion. This will be the conclusion of our again lectures on how to enter data and also organizing the data. In this case, we talk about quantitative data. Again, these lectures cover chapter 9 of our course textbook. Again, if you have any question, you can send an email or you can reach me at my number. So again, wish everybody the best and thank you for your time.